In this tutorial, we're integrating excellent procedural recoils into FPS Multiplayer Template 6. We'll replace the template's default recoil implementation, integrate the required systems, and configure the framework step by step. I'll clearly explain each part of the setup process while keeping the implementation clean, straightforward, and easy to follow. By the end of this video, the template will be fully integrated with excellent procedural recoils. Before starting the integration, we'll make a small adjustment to the template to speed up the testing workflow. Open the test_level, then open BP_conquest_GS. Inside the blueprint, select match settings and set pre-match time to 1 second. This allows the match to start almost immediately whenever we press play, making it much faster to test the recoil implementation throughout the tutorial. Next, we'll disable the template's default recoil implementation to prevent conflicts with excellent procedural recoils. Open BP_player character and search for playfire weapon montage. We can simply disconnect this node. After that, search for recoil. Disconnect both add recoil pitch and add recoil yaw. We'll also disconnect add recoil together with the set timer by function name node that was previously used to reset the template recoil values. Next, press Ctrl+P and search for bn_camera shake notify. This is the template's default camera shake implementation. We'll disconnect this as well so that all camera movement and recoil behavior comes directly from excellent procedural recoils. If we press play now, the weapon should still fire normally, but without any recoil or camera shake applied. Next, we'll set up the weapon blueprint integration. Open BP_base weapon, which is the template weapon blueprint, and also open BP_weapon base, the example weapon included with excellent procedural recoils. We'll use this blueprint as a reference to quickly copy the required functionality. Inside BP_base weapon, create two new variables, anim recoil definition and camera recoil definition. Set their types to PDA_animated recoil definition and PDA_camera recoil definition. These two variables define the weapon's recoil behavior for both the procedural animation recoil and the procedural camera recoil system. Compile the blueprint and assign the default data assets to avoid possible null reference conflicts. Navigate to the fire weapon event graph and create some space around the shoot logic. This is where we'll trigger the recoil components whenever the weapon fires. Switch to BP_weapon base, open the function list, expand the implementation category, and select request start procedural recoils. Copy the function with Ctrl+C, return to BP_base weapon, click inside the graph, and paste it using Ctrl+V. This function is responsible for triggering both the procedural animation recoil and the procedural camera recoil. Because the template and excellent recoils use a different fire mode, enum, we need to slightly adjust the implementation. Call getFiringMode, duplicate the comparison nodes, connect them to the new firing mode enum, and set the values to auto and burst. Reconnect everything to the OR operator and remove the old nodes. Once that is complete, return to the shoot event and call the new request start procedural recoils function whenever the weapon fires. We also need to notify the recoil components when the weapon stops firing. Go back to BP_weapon base, copy request stop procedural recoils, and paste it into BP_base weapon. Create a new custom event called stop shoot and call request stop procedural recoils. At this point, the weapon blueprint integration is complete. Next, we'll set up the character. Open BP_character, and also open BP_player character. Inside BP_player character, search for the function stop shotting with 1 O. Here, get the inventory component and access the current weapon reference. To prevent possible runtime errors, right-click the pin and convert it into a validated get. From here, call the new custom event stop shoot. This ensures that whenever the character stops firing, the weapon also informs the recoil system that shooting has ended. Next, select mesh_FPP. and add a new tag called first person. Do the same for the camera component, but additionally add the tag recoil. Excellent Procedural Recoils uses these tags to automatically locate the correct components during runtime. Now add both recoil components, BP underscore animated recoil component, and BP underscore camera recoil component. Next, return to the example character and copy the function update procedural recoil definitions into the template character. Inside the function, get the current weapon reference just like before and access the recoil definition variables we created during the weapon setup. Connect the animated recoil definition and the camera recoil definition like so. We also need to provide the weapon fire rate. FPS multiplayer stores the firing rate as intervals, while excellent Procedural Recoils expects the value as rounds per minute. To convert the value correctly, divide 60 by the weapon's fire rate. Next, search for on weapon equipped and call update procedural recoil definitions at the end of the logic. This ensures that the recoil system updates automatically whenever the player switches weapons. Next, we'll implement the required blueprint interfaces. Open class settings and add both recoil interfaces. After compiling the blueprint, Unreal Engine automatically adds all required interface functions. Start with the first function, getADS alpha, getMesh underscore FPP, access its anim instance and cast to ABP underscore base underscore FPP, access the aim alpha value and return it like so. Here, simply get the recoil data assets from the current weapon and return them. For getWeaponDebug info, provide the required weapon information values just like this. Now double-click each of the yellow interface functions to place them into the event graph. For stop aiming, simply call the existing stop aiming event, double-click into it to navigate to the aiming implementation inside the character blueprint. Here, create a new custom event called Debug Start Aim, then use it for the Start Aiming interface event. For the fire events, simply call the corresponding weapon events like so. These 4 interface events are only used by the Recoil Debug Widget, which allows us to quickly create and iterate recoil definitions. We'll cover that system in more detail in a future video. Next, continue with the Procedural Camera Recoil interface. To determine whether the weapon is currently firing in automatic mode, create a select node and configure it like this. For camera underscore getADS alpha, simply duplicate the previous implementation. The next function, getControllerInput, is used by the camera recoil component to measure how much the player is actively controlling the recoil. Create 2 new variables, input pitch delta and input yaw delta. Search for lookup and set input pitch delta like so. Then search for on turn and set input yaw delta the same way. We also need to reset these values whenever the player stops moving the camera. Connect the reset logic to the completed execution pin. At this point, the character blueprint setup is fully integrated. Next, we'll set up the animation blueprint so that the procedural animated recoil can actually be applied to the arms. Start by searching for ABP underscore procedural animated recoil. Before we can use it, we need to assign it to the correct skeleton. Select SK underscore mannequin from the template using this path right here, then click accept. We can already open the animation blueprint, but for now, switch to the template's main first person animation blueprint, ABP underscore base underscore FPP. Inside the anim graph, create a new linked anim graph node and set it to ABP underscore procedural animated recoil and add the tag recoil. The recoil component uses this tag to automatically locate the correct animation instance during runtime. Connect the node directly before the final output pose. However, we still need one additional layer between the recoil graph and the final output. Open ABP underscore first person arms, which is the example animation blueprint included with excellent procedural recoils. First, disconnect this section right here to avoid compile errors, since we no longer need this animation blueprint inside the project. Next, open the animation layer called 2Bone IK and copy all of these nodes. Now return to ABP base FPP. Click the plus icon to create a new animation layer and name it TwoBone IK. Paste the copied nodes into the new layer, then select the layer and add an input pose. Return to the anim graph and place the new TwoBone IK layer between the recoil graph and the final output pose. Next, switch back to ABP underscore procedural animated recoil. Inside the anim graph, locate the transform modify bone node and change the translation space to component space. After that, open Blueprint Thread, Safe Update Animation, navigate to Update Final Transform, and adjust these pins right here so that the recoil rotations properly match the rotation setup used by the FPS multiplayer template. Finally, go to the Apply Aiming Bone Position section and change both Transform Modify Bone nodes to use IK Handgun. This ensures that the aiming system and the procedural recoil system are calculated correctly together while aiming. At this point, the animation blueprint setup is complete. Before we finish the setup, we still need to copy a few nodes required by the recoil debug widget. Open BP underscore character and navigate to the demo graph. Copy all of these nodes right here. Return to the template character, BP player character, and paste them into the event graph. This enables us to toggle the visibility of the debug widget using the tab button. Finally, open WB underscore HUD, select the root widget and change its visibility setting to not hit testable, self, and all children. This prevents the HUD from blocking mouse interaction while using the recoil debug tools inside the editor. The debug widget setup is now complete. The final step is assigning recoil definitions to the template weapons. To quickly locate the weapon blueprints, search for BP underscore pistol, select the blueprint, and press Ctrl plus B to reveal it inside the content browser. Inside the folder, hold Ctrl and select all weapon blueprints that should use procedural recoil. Right-click the selection and choose Edit Selection in Property Matrix. This allows us to quickly assign recoil definitions to multiple weapons from a single window. Make sure the Details tab is selected. Now select the first weapon and assign a recoil definition pair that matches the weapon type. For the assault rifle, I'll use the Rifle 1 recoil definitions like this. Repeat the same process for the remaining weapons. Note that BP underscore rifle is actually a sniper rifle, so I'll assign the sniper recoil definitions to that weapon. Once all recoil definitions are assigned, close the property matrix window and press Save All to save the entire project. And with that, excellent procedural recoils is now fully integrated into FPS Multiplayer Template 6. We now have fully procedural animated recoil, procedural camera recoil, camera shakes, and offsets integrated directly into the template. Let's quickly take a look at the included editor utility widget, which allows us to rapidly tweak and iterate recoil definitions directly inside the editor. We'll cover that system in much more detail in the next video. Before you start tweaking recoil definitions, make sure that the debug variables are enabled inside both the procedural animated recoil animation blueprint and the camera recoil component. Let's also slightly adjust the editor layout for a better recoil tweaking workflow. I'll close the content browser and the outliner so we have a cleaner view of the recoil debug panels while playing. Once we press play, we now have a much better overview of both the weapon recoil and the recoil definition settings on the right side. The editor utility widget automatically detects the currently equipped weapon and updates the correct recoil data assets in real time. You'll notice that the mouse cursor is locked inside the viewport. To move the cursor outside the viewport again, simply press Shift plus F1. When pressing Show Anim Recoil, the panel displays all variables related to the procedural animation recoil system. Pressing Show Camera Recoil loads the corresponding camera recoil data asset. The animation recoil data asset is built around multiple recoil layers that operate independently from one another, combined with general settings that affect the entire system globally. On the left side, you'll also find useful debug information such as current recoil values and alpha timings for every layer. We can also enable start auto fire, so we don't need to continuously shoot manually while tweaking recoil values. You can control the shot count per interval, pause duration between intervals, and individually enable or disable recoil layers and axes. For example, once I start aiming down sights and enable auto fire, the weapon currently recoils a bit too heavily into the camera for my taste. Let's fix that quickly using our editor utility widget. Inside the general ADS location scalings, I'll reduce the y-axis value to 1. This updates immediately in real time and already looks much better. Notice that the Hipfire recoil remains completely unchanged. Next, I think the camera recoil is slightly too strong overall, so I'll switch to the camera recoil settings and reduce the general scale to 0.12. Again, the result updates instantly. You also have full control over recoil randomization, including independent flip-flop behavior for every axis, either randomly or after every shot. One of my favorite sections is the camera shake setup. This system is divided into two separate parts, initial fire and continuous fire. For example, if I double the initial hipfire scale to 2, the first shot becomes much more impactful and immersive. You also have access to multiple camera shake duration presets, including blended and non-blended variants. For example, I can select the 0.35 duration without blending, which creates a much more aggressive initial camera shake behavior. I'll then reduce the scale back to 1 since it matches much better with the new camera shake duration. Let's look at one more example using the pistol recoil. I'll increase the general yaw rotation scale, which makes the weapon appear much more unstable. Now when switching into ADS, I'll lower the ADS yaw rotation scale to simulate the character stabilizing the weapon more effectively while aiming. I'll also slightly lower the overall ADS scaling values while still keeping a stronger backward kick into the camera. After that, I can continue fine-tuning the hipfire scalings until the weapon feels exactly the way I want. You can also adjust recoil stiffness. Lower values create softer and less snappy recoil behavior, but 0 results in instantaneous movement. Let's also quickly look at some of the recoil layers themselves. For example, the snap layer. Most layers share a very similar architecture while serving different animation purposes. They all include base values, transform values, scalings, and randomization controls. A good example is the advanced detailing layer, which is primarily responsible for giving the weapon its overall recoil personality. This layer uses independent curves for location and rotation and evaluates them differently on every shot through randomization. And for example, I can open the rotation curve and slightly tweak its shape. I'll also reduce the curve evaluation speed by half, so the recoil animation becomes less snappy and lasts a little longer. As you can see, the pistol recoil now has additional micro movement toward the end of the animation and feels much more dynamic overall. And that's essentially it for this video. I hope this tutorial helped you successfully integrate excellent procedural recoils into your own project. If you still have questions regarding implementation, recoil design, troubleshooting, or workflow tips, feel free to ask them in the comments. Create, expand, deliver.